This is one of several application examples using the Tektronix RSA5100A real-time spectrum analyzer. In this application, the Tektronix RSA6100A is tuned to a simulated radar signal. It has a pulse repetition frequency of about 41 kHz and a 170 nanosecond pulse time. The RTSA has a center frequency setting of 1 GHz, a span of 40 MHz, and a resolution bandwidth of 390 kHz. As expected, you can see the sin X over X characteristics of a pulsed radar signal, and from this you can easily determine things like the pulse width and spectral occupancy. However, the RSA6100A shows something that is very hard to detect and that could be easily overlooked on a traditional swept spectrum analyzer. Here you can see a low-level signal sweeping across the frequency span. The Tektronix RSA6100A uses patented digital phosphor, or DPX, technology, so it not only captures fast-moving transients like the radar signal, but also other signals that are well below the level of the main signal. And now, by simply changing the attenuation setting on the RSA6100A, we get a much more pronounced look at the embedded spurious signal. DPX technology requires dedicated digital signal processing hardware performing over 48,000 discrete Fourier transforms per second. The human eye can only process 33 frame updates per second, so the RSA6100A uses color to distinguish frequently occurring events from brief transients. In this example, the more frequent events are indicated by the more intense green color outlining the pulsed spectrum shape. This way of seeing a signal can be useful in applications such as a radar monitoring station or an engineering test stand, having the ability to see a low-level interference signal even when it's masked by the main radar signal. To get the rest of the picture, the RSA6100A takes over 48,000 snapshots of the complete span per second. Plus, it uses a persistence display to show how the signal varies over time. DPX provides the engineer with much more meaningful and complete information about all the signals that are present in the span of interest. The RSA6100A is able to give engineers greater ability to see how signals vary over time and show them signals that other analyzers miss.